This is 3.4, day 1. We are going to focus on this lesson on trying to find out what is the value of x. And there are different tools that we will use. We will use the one-to-one property a lot. We will use the inverse property a lot. And then sometimes we'll rewrite to a different form, maybe from a logarithm to an exponential or vice versa. So this first example is probably pretty easy, that you may be able to identify what the value of x is right now. So you say you have an exponential, 2 to the x equals 32. What could x equal? What do you think it would equal? 5. So I'm going to show you 2 different ways to do this problem. One is just to rewrite both sides to an exponential form. So this one is fine, it's 2 to the x. How do I rewrite 32 to the same base? So like 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6. Which one would it be? 2 to the 5. 2 to the 5th power equals 32. So now I can use the one-to-one property. It says I have an exponential on both sides and they're both a base of 2. That means then their powers must equal each other. So these two must equal each other. So you get a value of 5. Another way, because sometimes this method doesn't work with every problem, because that 32 might not be able to be rewritten to the same base of 2 on the right side. So another way is you could multiply both sides by a logarithm. So here's another way. So we have that original problem, 2 to the x equals 32. What you can do is you can multiply both sides by a logarithm. A lot of times students just use natural log, but you could use common log. So I multiply both sides by the natural log, so it looks like this. Then I learned about a property earlier this chapter. What can I do with that x power? Where can the x power go? It can go down in front. So now it looks like this. X natural log of 2 equals the natural log of 32. And then what'd you say? Very good. Then you can divide both sides by the natural log of 2. So you're left with x on the left, the natural log of 32, divided by the natural log of 2. Then you'd have to take out your calculators. The natural log of 32 divided by the natural log of 2, what should you get for an answer? You better get 5 or something's going wrong. What if I used common log instead? Still will work. The common log of 32, so log base 10 of 32 divided by the log of 2. I also get 5. So that's another way to be able to do this problem. So one of the difficult things as a teacher when I grade this next test is maybe you did it one way, but another student did it another way. There's going to be multiple ways to do some of these equations by solving for x. So that'll be some fun. All right, so let's go up to this one, question B. The natural log of x minus the natural log of 4 equals 0. How do we solve for x? What could we do? You could put it back to a 1 log. Might not help you with solving it though. That is a property that we learned though. You can combine them back into 1 logarithm. Anything else you can do? It's okay if you don't know. What about if I do this? I say the natural log of x equals the natural log of 4. I add in the natural log of 4 to both sides. How does that benefit me? Very good, 1 to 1. I have a logarithm of base e on the left. I have a logarithm of base e on the right. Then the one-to-one property says these must equal each other. So x equals 4. Or look at the equation. The natural log of x minus the natural log of 4 equals 0. How do I get that to equal 0? That has to be the same natural log of 4. It's another way to do it. Okay, question C. We have an exponential of base 1/3. A little bit more difficult. Raised to the x equals 9. And we want to find out what is the value of x. So think back to that first example that we did. 2 to the x equals 32. We showed you two different methods to do it. Same thing here. Which one do you choose? The first method, okay? So I need to rewrite both sides so they have the same base. They're both exponential. So how do we rewrite one of those two sides so they're exponential? What? Oh, you want to take the natural log of both sides?
Yeah.
Oh, that method, the second method then. So take the natural log of both sides. And then what do I do? Bring the x in front, yep. And then what? Yep, and then divide both sides by the natural log of 1/3. Be careful with that denominator's natural log. What does x equal? Do you want to do the other way? Care? Want to show the other way? Or I have 1/3 raised to the x equals 9. How can I rewrite 9 or 1/3 to the same base? Okay, let's talk about 9. 9 is a nicer number. Can I rewrite this to 3 squared? We're getting close. How can I rewrite 1/3 to a base of 3? 3 to the -1. Do you agree with me that 1/3 is the same as 3 to the -1 power? Remember those fractions can flip back up. Now this is a power to a power rule that says 3 to the -1 raised to the x. We multiply those together. Now we can use the 1-to-1 property. I have an exponential of base 3 on both sides. So then their powers must equal each other. So -1x equals 2, and then divide by -1, and we get -2. There's another way to do it. Okay, let's go on to example D. We have an exponential, and that exponential is base e, which remember is about 2.71. And we raise it to the x equals 6. We want to find out what is the value of x. What can we do here? Probably only the first method this method would work on the left over here, because it would be really hard to rewrite 6 as an exponential of base e. So now we'd want to take the natural log, and it's definitely you want to take the natural log and not the common log. Why do you think take the natural log instead of the common log? They cancel out. We learned earlier in the chapter that I have a log of the base e and an exponential of base e. What happens to this left side? It cancels out, and we're left with what that power value is, which is x. And then our calculators become useful. Throw it into your calculator. The natural log of 6 is 1.7. Give me one more placeholder. Approximately 1.79. Stop the recording there.